Earthquakes. These sudden, violent shakes of the ground can topple buildings, crack roads, and trigger tsunamis. They are a stark reminder of the immense power that lies beneath our feet, a power that has shaped our planet for billions of years. We may walk on solid ground, but the Earth is a dynamic, ever-changing system, and earthquakes are one of its most dramatic expressions. From the gentle tremors that we barely feel to the catastrophic quakes that make headlines around the world, these seismic events are a constant presence in many parts of the globe. Understanding earthquakes is not just about satisfying scientific curiosity, it's about protecting lives and building resilience in the face of natural disasters. By delving into the science of earthquakes, we can gain a deeper appreciation for the forces that shape our planet. We can also learn how to better prepare for these events and mitigate their devastating impacts on human lives and infrastructure. To understand earthquakes, we must first understand the systems that create them. These systems are driven by the movement of Earth's massive tectonic plates, which constantly interact with each other, generating immense forces. These forces are responsible for building mountains, creating ocean basins, and, of course, triggering earthquakes. Imagine Earth's surface as a giant jigsaw puzzle, with each piece representing a tectonic plate. These plates are not static. They are in constant motion, albeit very slow motion, moving a few centimeters per year. It is at the boundaries of these plates where most earthquakes occur. As the plates grind against each other, stress builds up over time. This stress is eventually released in sudden bursts of energy, which we experience as earthquakes. The location where this energy is released is called the earthquake's focus, while the point directly above it on the Earth's surface is known as the epicenter. The Earth's crust, the outermost layer on which we live, is not a single solid shell. Instead, it's broken into several large pieces called tectonic plates. Think of these plates as giant rafts floating on the Earth's semi-molten mantle. The heat from the Earth's core creates convection currents in the mantle, which in turn drive the movement of the tectonic plates. There are 7 major tectonic plates and numerous smaller ones, all interacting in a slow-motion dance across the globe. These interactions can be constructive, destructive, or conservative, depending on the direction and type of plate movement. These interactions are not always smooth. Plates can collide head-on, grind past each other, or even pull apart. It's at these boundaries where the plates meet that most of the Earth's seismic activity occurs. Fault lines are fractures or zones of weakness in the Earth's crust, where rocks have moved past each other. They are the battle scars of the Earth's tectonic plates, marking the locations where the immense forces of plate movement are most evident. Most earthquakes occur on pre-existing faults, although new faults can form under the right conditions. There are different types of faults, each associated with a specific type of plate movement. Normal faults occur where plates are pulling apart, reverse faults where plates are colliding, and strike-slip faults where plates are sliding past each other horizontally. As stress builds up along a fault line, the rocks on either side can deform, bending and warping until they can no longer withstand the pressure. When the stress exceeds the strength of the rocks, the fault ruptures, releasing energy in the form of seismic waves that travel through the Earth, causing the ground to shake. Section 5. Measuring the unseen, the science of seismology. Seismology is the study of earthquakes and the propagation of elastic waves through the Earth. Scientists who study earthquakes, called seismologists, use a variety of instruments and techniques to monitor seismic activity, analyze earthquake patterns, and learn more about the Earth's interior. One of the most important tools in a seismologist's arsenal is the seismograph, an instrument that detects and records ground motion caused by seismic waves. Seismographs produce seismograms, which are visual records of the Earth's vibrations. By analyzing seismograms from different locations, seismologists can determine the location, depth, and magnitude of an earthquake. They can also use this information to study the Earth's internal structure, map fault lines, and assess seismic hazards. Section 6. Predicting the unpredictable. The quest for earthquake forecasting. Predicting earthquakes with accuracy remains a significant challenge for scientists. While we can identify areas at high risk of earthquakes based on historical seismicity and fault mapping, pinpointing the exact time, location, and magnitude of a future earthquake is still beyond our current capabilities. However, research into earthquake prediction continues, with scientists exploring various avenues, including monitoring precursory phenomena. Some scientists believe that subtle changes in the Earth's crust, such as ground deformation, radon gas emissions, or electromagnetic fluctuations, might precede earthquakes. Statistical analysis. By analyzing historical earthquake data, scientists can identify patterns and trends that might provide clues about future events. Developing early warning systems. While not a prediction tool, early warning systems can provide valuable seconds to minutes of notice before the strongest shaking from an earthquake arrives, allowing for automated actions like stopping trains, shutting down gas lines, and alerting emergency responders. While a foolproof method for earthquake prediction remains elusive, ongoing research and technological advancements offer hope for improved forecasting in the future. Section 7. The Aftermath: Understanding Earthquake Impacts. The impact of an earthquake depends on several factors, including its magnitude, depth, proximity to populated areas, and the quality of local building construction. Earthquakes can cause a wide range of damage, from minor tremors to catastrophic destruction. Some of the most common and devastating effects of earthquakes include ground shaking. The most immediate and widespread impact, ground shaking can topple buildings, damage infrastructure, and trigger landslides. Surface faulting. When a fault ruptures at the Earth's surface, it can create large displacements, offsetting roads, fences, and even rivers. Tsunamis. Underwater earthquakes can displace massive amounts of water, generating tsunamis, giant waves that can travel across oceans and inundate coastal communities thousands of kilometers away. Understanding the potential impacts of earthquakes is crucial for disaster preparedness, mitigation efforts, and the development of building codes that can withstand seismic events. Section 8. Living with Uncertainty. Earthquake Preparedness. While we cannot prevent earthquakes, we can take steps to minimize their impact and protect lives. Earthquake preparedness involves a combination of individual, community, and governmental efforts. Some key aspects of earthquake preparedness include securing your home, fastening heavy objects, reinforcing shelves, and installing flexible gas and water connections can reduce damage and injuries. Developing an emergency plan. Knowing what to do during and after an earthquake, having a communication plan, and assembling an emergency kit can save lives. Supporting building codes. Enforcing strict building codes that incorporate seismic-resistant design principles is crucial for reducing structural damage and casualties. By taking proactive steps to prepare for earthquakes, we can foster resilience and create safer communities in earthquake-prone regions. Section 9. Conclusion. Respecting the power of the Earth. Earthquakes are a powerful reminder of the dynamic nature of our planet. They are a force that can both inspire awe and inflict destruction. While we continue to unravel the mysteries of earthquake-generating systems, one thing remains certain. We must respect the power of the Earth and learn to live in harmony with its ever-changing rhythms. By understanding the science behind earthquakes, investing in research and technology, and embracing a culture of preparedness, we can mitigate the risks and build a safer future for ourselves and generations to come. The Earth will continue to rumble and shake, but our knowledge and resilience can help us weather the storms.